Hello everyone, I'm Monika Bhushan and today we are starting lecture number 11 of linear algebra. Since few classes we are studying the concept of rank and we are finding out the rank using different methods. Fine. In today's class also we are going to find the rank of a matrix but using some other method. Okay, so here is the question where we have to find non-singular matrices P and Q such that the matrix PAQ, okay, this A is given to us. The matrix PAQ is in the normal form given by this matrix A is given to us, okay. This matrix is what? The 3 rows are there and 4 columns are there. So this is 3 cross 4 matrix. Then we have to find the rank of the matrix. So basically we are seeing different methods to find the rank of a matrix. Okay. So we have already covered two very important methods to find the rank of a matrix. One was the REF method. Okay. And the second was reduce the matrix into normal form. So we are not going to again go into those details. And I assume that you know very well what is the normal form of a matrix. And we have covered these definitions also, right? That what is non-singular matrix and all. Okay, so what is non-singular matrix? We have covered in very first class only that the square matrix is said to be singular matrix if the determinant of this matrix will be 0. Okay, but they are saying us to find the non-singular matrices P and Q. Okay, P and Q will be non-singular matrices. That means for sure P and Q will be the square matrices, and the property of that square matrix will be what? That the determinant of these matrices will be non-zero. So that means the determinant of P will not be 0 and the determinant of Q will not be 0. Fine. So this is only the property of non-singular matrices P and Q. Okay, so since we have covered these many things, so we are just going to start the question that how to find the rank of the matrix in this method. Okay, so the matrix is already given to us, and then what they are saying us, what my answer will contain. So my answer will contain the matrix P and the matrix Q. Okay, so these matrices are non-singular matrices such that this arrangement, that is PAQ, will be in normal form, and then we will have to find the rank of the matrix. Okay, so these three things we have to find in this question. Okay, so let's start this question. So here is the method. Order of matrix A is 3 cross 4. Fine. This is the matrix which is given to us, and we have seen that the order is 3 cross 4. That means 3 rows and 4 columns. Hence, in this method, what we are going to do, we are going to take the prefactor of the matrix A and post factor of matrix A. Okay, what are these prefactor and post factor? Okay, so basically this is the prefactor and this is the post factor. Okay, so what I'm doing here, they have said us that PAQ should be in the normal form. Okay, this prefactor and post factor are nothing but the identity matrix. Okay, prefactor will be written before this A. Okay, here I'm going to write down the prefactor. That prefactor will also be identity matrix. Some identity matrix we are going to see what. Even this post factor is what? This will also be some identity matrix. Okay, the prefactor will contain order 3 of identity matrix and post factor will contain order 4 of identity matrix. That means here I am going to write down I3 and here I am going to write down I4. Why I am doing so? Because I know that this matrix A has order 3 cross 4. Okay, fine. So to find the rank of the matrix using this specific method, what I am going to do? I am going to write down the matrix A between prefactor and post factor. The prefactor and post factors both will be the identity matrix. This identity matrix will have the order 3 and the post factor of A will have order 4. This will be the arrangement. Fine. And that I am going to relate with this matrix A. So this is the step number 1, very important step. The step number 1 says that put the matrix in this specific arrangement. This specific arrangement says that this is the matrix which is given to me. This is A, okay, and then this is my I3, and we have discussed in almost all classes what are the identity matrices. So this is my identity matrix of order 3. Fine. So if it is identity matrix of order 3, that means for sure it will be my square matrix, and for sure this post factor is also the square matrix. Post factor has the order 4, so 4 rows and 4 columns will be there, and this prefactor will have 3 rows and 3 columns, and the identity matrix contains 1 in the diagonal and all other places it has 0. Similarly, here 4 rows and 4 columns are there, and the diagonal has 1, all other places it has 0. Fine. So this is my I3, this is my I4. Okay. Now what I'm going to do, my step number 2 says what? Step number 2 only I have to concentrate that. Here they have said that the matrix PAQ, okay, this matrix PAQ is in the normal form. Okay, so that means this arrangement what we have made here, what we have to do, we have to reduce this matrix A into the normal form. Okay, so to reduce the matrix into normal form is exactly the same thing what we have discussed in the last class, the lecture number 10. Only the important thing here is, if I'm performing the row transformation, okay, then the row transformation will get applied in the prefactor. Okay, in the prefactor you are going to use the row transformation. Okay, and if I'm performing the column transformation, then I have to perform on the post factor of matrix A. So in post factor only column transformation will get performed. Okay, and in the prefactor only row transformation will get performed. So I'm starting with this step number 2. What I'm going to do here, so this is my matrix which is given to us, and then I have to convert this matrix into the normal form. So to convert the matrix into normal form, what we do, we first convert the matrix into REF form. Okay na, we first convert the matrix into REF form by only row transformation. Okay, by only row transformation. So what we are going to do, so my first focus is what, my first focus is this number. This is 4 written, but I really wanted to have 1 in this place, which is the first row, first column. But not always it is possible to have 1 here unless I am going to divide it. But right now I am not interested in dividing it by 4, because here I will get the fractional numbers, and I don't want to include the fractional numbers right now. Okay, so for that what I will do, I will try to put some lower values. I think that by any row transformation can I make 1 here, but I don't think that I will be able to put 1 here. Okay, so what I'm going to do, I'm going to interchange row 1 with row 2. Okay, and why I'm doing so, row 2 is also 2, this is not 1. So what is the use of interchanging row 1 with row 2? Because row 2 is having the lesser value than row 1. So 2 is lesser than 4. If it was 1, it was always better. But if it is 2, but still 2 is lesser than 4, so it will be far easier to have the calculation. So I am going to interchange row 1 with row 2. I should not interchange row 3 with row 1, because 0 is not at all allowed in this first place. Okay, so I am going to interchange row 1 with row 2. Okay, if you really don't want to interchange, you may leave also, but if you are writing down the lower value at this first place, so it will be easier for further calculation. Okay, what my next focus is, my next focus is this number. Fine now. So this is what? This is the second row, first column. Here I have 4. My REF form says what? My REF form says that ideally this place should contain 1. Right now this place should contain 1, and below this leading 1 I should have zeros present. Okay. So right now I know that this is 2, not 1, but later I will make it 1. Right now I don't want to even divide it by 2, otherwise I will get the fractional values here, here, here. So I'm not interested to include the fractional value right now. So I'm keeping this 2 as it is, and then what I'm going to do, for having 0 in this place, what should I do? I'm going to perform R2 as what? Minus 2 R1 plus R2. So minus 2 R1 will be minus 2 into 2 minus 4, and then plus 4. Yes, I will be getting 0 here. Fine. And the same operation I have to perform at this place also, and this place also. Fine. Okay, and one more thing, what we have discussed, that whatever operation, whatever row operation I am performing on this left hand side, the row operation I have to perform on this matrix also. Okay, not on post factor. That means the pre-factor will be having the row transformation and the post factor will be having only the column transformation. No column transformation will be allowed in the pre-factor. No row operation will be allowed on the post factor. Fine. So here what we had done, we had interchanged row 1 with row 2. So here also we have interchanged row 1 and row 2. Okay. So it is what, row 2 is now row 1 0 1 0 and 1 0 0 is at the second row. Fine. Okay. So second thing is what, whatever operation I am performing here, I have to perform at this place also. Okay. So later what I am going to have here. So this is after the row operation I have got, and even after this row operation I have got here these values. Fine. No, which operation? Minus 2 r1 plus r2 we have done here also. Suppose, okay, so that means what I am going to do at this place, what should have, right now this is 1, but later it will be having what, this is my minus 2 into r1. Okay, no, minus 2 into r1 is 0, so minus 2 into 0 plus r2 is 1. So this is what, this is 0. Fine. No, minus 2 into 0, this is 0 plus 1, so nothing but 1 only. Okay, so here I'm going, fine, so here I'm going to get 1. Similarly, the same operation is going to perform on this place also, this place also. So we have got 1 minus 2 and 0. We are not performing this row transformation in post factor. Post factor is as it is. So what next I have to do? You can see here that this R3 is 0, 1, 2, minus 2, and R2 is what? 0, minus 2, minus 4, 4. That means if you are dividing this R2, okay, by minus 2, so what will happen? So it will be what? This will be 1 and then it will be then 2 and then minus 2. Fine. No, this row operation is what? I am going to divide R2 with minus 2. And why I am doing this division operation? Because here division operation is always safe. I am going to get the integer value only. So I am writing down here 0, 1, 2, minus 2. Fine. No, after this division, and then the R3 is as it is. Similarly, same operation, whatever I have performed in the left hand side, same operation I have to perform on the right hand side also. But in the right hand side, I have to perform on the prefactor. Why? Because this is the row operation. If it was column operation, then I had to perform on the post factor. Fine. So same thing if I have done here, that means R2 is divided by minus 2. So R2 divided by minus 2 will be minus 1 by 2. And then this will be your 1 minus 2 divided by minus 2. And then 0 divided by minus 2 will be 0 only. Fine. So here fractional value or all I am not interested at all. Fine. So now what I am going to perform? I can see that R2 and R3 are exactly same. So what I am going to do? I am writing down R3 as R3 minus R2. If I am performing this row operation in the left hand side, I have to perform the row operation in the right hand side also. Okay. So here this is what, the R3 is 0 and here R1 is as it is, R2 is as it is, R3 is what? I'm going to write down R3 minus R2. That means 0 minus of minus 1 by 2, it will be plus 1 by 2. Okay, then 0 minus 1 is minus 1 and then 1 minus 0 is 1 only. Okay, so till here things are okay. This is always in my mind that this is not in the REF form. Why this is not in the REF form? Because the first non-zero number should be 1. Okay, so at this step, I'm going to divide this row number 1 by 2. Okay, so fine. So what is the use of dividing it at the end? Because now if I'm dividing it by 2 and I'm getting the fractional values, so still my answer will have the accuracy. Only this is the reason to do the division at the end if it is not giving me the integral values. Okay, so on practicing few examples, these things will get clear that okay, at which step I have to do which kind of row or column transformation. Okay. Okay, so now what I'm going to do, R1 is what? R1 divided by 2. So whatever row operation I'm performing in the left hand side, same row operation I have to perform in the right hand side also, but only in the prefactor. Okay, so this is my 1 0 0 and whatever I have got here, yes, this is my REF form. You know very well what is the REF form. We have discussed very well many times in the previous lectures. So this is my REF form. So the row transformation is done. Once we have reached to row echelon form, we stop doing the row transformation and we start performing the column transformation to convert the matrix into the normal form. Okay, na? Last class also we have seen the same thing. So finally we have got actually this arrangement. Okay, so this arrangement is what? This is the matrix P, which is my answer P. Now I have to start on finding the matrix Q. That means this I4, okay, now this identity matrix of order 4 is only going to convert into the matrix Q. And how it is going to convert into matrix Q? Once I will start performing the column transformation in my left hand side, same column transformation I have to perform on the post factor also. Okay, and if I will reach to the final normal form of this matrix A, so whatever matrix will be present here, that will only be my matrix Q. Okay, fine. So what I have to do here? So this is my REF form. I have to reduce this matrix into the normal form. For that, what I have to do? This is perfectly okay, 1 0 0. But I am seeing that here, instead of 1 by 2, I should have 0. Okay. Even instead of 3 by 2, I should have 0. Instead of 1 by 2, I should have 0. Fine. So for that, which operation I am going to perform? I am going to perform the column transformation. Fine. No. C2 will be what? Minus 1 by 2 into C1 plus C2. Similarly, C3 will be what? Minus 3 by 2 C1 plus C3. C4 will be minus 1 by 2 C1 plus C4. And why we are doing so? We have discussed these things right now in the last class only, to make these places 0. Okay, so whatever operation I am performing on the column, I have to perform on each and every element of the column. Okay, because here I am going to view the matrix as column wise. Okay, no. What I'm going to do here, this complete P is as it is. I'm not going to touch P. Whatever column transformation I am performing on the left hand side of the matrix, same column transformation I have to perform on the post factor on right hand side also. Fine, no? Okay, so that means here I'm going to perform same thing here also. So C2 is now minus 1 by 2 C1 plus C2. So if I'm seeing this I4, okay, so here the same thing I'm doing right now, this C2. This is my C2, this is my C1. So C2 is now what? C2 is minus C1 by 2 plus C2. So I will be getting here minus 1 by 2. Similarly, I have to perform on each and every element on this column. So I have got the new values which are here. Similarly, this C3 transformation is done here. Okay, similarly, this C4 transformation is done here. Okay, so finally, we have got this arrangement of numbers. Okay, now what I'm going to see here, can I say that this matrix is in the normal form? So no, still this is not in the normal form. Why? Because this column 1 is perfectly okay. This column 2 is also perfectly okay. This is my leading one, and before leading one and below leading one, I have 0. That is okay. But I can see that here I should have 0. Fine. No, why I should have 0? Because this R2 should be having only one non-zero element, which is 1, and that is already present, and after this one I should be having 0 in all places. Okay, my focus is actually at this place. So for that, what we are performing? C3 right now. This is what? C3. So this C3 will be what? Minus 2 C2 plus C3. So minus 2 C2 plus C3. So if 0 0, so I will be getting 0 only in the first and third row. But in the second row at this place, what I am going to get? Minus 2 into C2. That means minus 2 into 1 will be minus 2 plus 2. That means 0. Okay, so we have got here. Similarly, the same operation we are performing here also. And whatever column operation I am performing in my left hand side, I have to perform on my right hand side also, but on the post factor. Similarly, this column transformation in the left hand side, this column transformation on the right hand side, but on the post factor. So for that case, C1 will be as it is, C2 will be as it is, C3 and C4 will only get changed, and we have done that, and we are seeing that C3 and C4 new numbers have come. Okay, so after this place, can I say that this matrix is in the normal form? So yes, this matrix is in the normal form. Why this is in the normal form? Because as the property of normal form which we have discussed, yes, this is satisfying all the criteria, and this is basically my I2. Okay, now so this arrangement is what? I2, right? I2 0 0 0. Fine. That means the row of this matrix A is what? 2. Two non-zero rows are there. So the rank of this matrix is 2. Fine. And since we have reached to the normal form, so now onward we don't have to perform any column transformation also. Okay. So that means this is the final post factor, and this final post factor is only called as Q. Okay, so they had asked three things. They had asked the P. So this matrix prefactor is P. Okay, this post factor matrix is Q, and the rank of the matrix is 2. And when we will understand that this is my final P and this is my final Q, once we have reached into the REF form, that means the arrangement of numbers in the prefactor is the final, which is the matrix P. And once we have reached to the normal form, then we will say that the arrangement of numbers in the post factor of matrix A is actually fixed, and that is only my Q. Okay, so this is my final answer. This is my P and this is my Q, and the rank of the matrix is 2. Okay, so this way we find the rank of a matrix using this method. Basically, we have seen three different methods to find the rank of the matrix. Any method you are going to perform, you are going to get the rank of the matrix as 2 only. So most popular method is, you can say that, by converting the matrix into the REF form, and similarly by reducing the matrix into normal form is also very well known. This is another method which is given in the syllabus. So we have seen how this method we use to find the rank of the matrix. Okay, fine. So if you find this class useful, please like and subscribe my channel. Thank you.